Hello everyone, happy to see you here. Today we have great algebra question k to the power 4 equal to k minus 1 to the power 4. We need to solve this question for k, so if you have your solution, your answer, you can also write that in the comment below and then we will check your answers. And a lot of students might be thinking, okay, we need to cancel this fourth power, we need to write something like that. A lot of students, this is the most common mistake I ever seen. A lot of students might be thinking, okay, square root of the fourth root of k to the power 4, we write something like that. And the fourth root of k minus 1 to the power 4, k minus 1 to the power 4. So we cancel these four, these for this square root, we cancel everything, and as a result, we have k equal to k minus 1. Yeah, we have something like that, and a lot of students cancel this k, and they say, okay, 0 equal to minus 1, and they say that this equation doesn't have roots, and they go to the next one. And I want to say that this is absolutely wrong approach. In the end of the video, I will explain you why this is a very bad thing to solve this type of question. So that's why I'm going to start to solve this question correctly and step by step. First of all, let's write these parentheses on the left side. So as a result, what do we have? We have k to the power 4 minus k minus 1 to the power 4, k minus 1 to the power 4 equal to 0. And right now we can easily consider it as a difference of fourth power, but in our case, let's write it as a difference of squares, yeah? We can write this k to the power 4 as k squared raised to the power 2 minus k minus 1 to the second power, and of course raised to the power 2. And right now we can consider this expression from a different angle. These are a difference of squares. These are a and these are b. So we are talking about a square minus b square. So a classic school formula, a square minus b square equal to a minus b, a plus b, or doesn't matter, we can change this sign. So a minus b, a plus b. So right now let's write it. As a result, we have a minus b, the first parenthesis, so we have k squared minus k minus 1 square, so k minus 1 square. Okay, first parenthesis, and the second parenthesis the same, but with the positive sign. So we have k squared plus parentheses, we have k minus 1 square, k minus 1 square equal to 0. So we have two parentheses and we can simplify it. So k square minus this parenthesis, so we have k square minus this one, we can evaluate it, we can simplify it, because k minus 1 square, this is our school identity. We have k square minus 2k and plus 1. These are the first parentheses, and we have absolutely the same second parenthesis. We have k square plus k square minus 2k and plus 1 equal to 0. I just write it with parentheses because this is extremely dangerous moment right now, and just be careful, because right here we need to change all the signs to the opposite. Okay, so we have k square minus k square plus 2k and minus 1. Okay, and another parenthesis, k square plus, right here we don't need to change all the signs, so k square plus k square minus 2k and plus 1 equal to 0. Okay, right now k square and k square we can easily cancel it. Right here we can add it, k square plus k square. So as a result, we have a product of two parentheses. We have 2k minus 1, and another parenthesis, 2k square minus 2k and plus 1 equal to 0. So a product of two parentheses equal to 0 when the first parenthesis equal to 0, so 2k minus 1 equal to 0, or another parenthesis, this one, so 2k square minus 2k and plus 1 equal to 0. So we have our two branches, and let's solve it. First of all, let's solve this one. So from here, 2k equal to 1 and k first equal to 1/2. This is our root, and then we will check it, and just a few seconds later we will we will check our root. Right now, let's solve this quadratic equation. This is a classic quadratic equation. Let's write our coefficients. So a equal to 2, b equal to -2, and c equal to 1. And let's, for example, solve for discriminant quickly. So we have b squared minus 4ac, b squared minus 4ac equal to b squared minus 2 square minus 4ac minus 4 times 2 and times 1. As a result, we have minus 2 squared. We have 4 minus 4 times 2 equal to 8. So 4 minus 8 equal to minus 4. So our discriminant is negative. So it implies that in this branch, we don't have real number roots, but we have two. So I just write it like that. So we have, in this branch, we have two complex roots. Two complex roots. We don't have real number root. We have two complex roots. So let's solve it. So we have k second and k third equal to all known formula. I hope you know it. So a minus b plus minus square root of discriminant and all over to a. So we have minus b minus minus 2 plus minus square root of discriminant square root of minus 4 and over to a 2 times 2. Okay, equal to, what do we have? Minus minus 2, we have 2 plus minus square root of minus 4. We can write it as square root of minus 1 times 4. We can write it as a product. We can write it like that. Minus 1 times 4 over 2 times 2 equal to 4. Yeah. Okay, so right now we can write it as 2 plus minus. Right here we can split it like square root of minus 1 times square root of 4, or we can write it as square root of minus 1 equal to I, square root of 4 equal to 2. So 2i over 4. Or the last tricky move, we're gonna divide each of this coefficient by 2. We're gonna cancel by 2. So saying in other words, we're gonna factor 2 from our numerator. We can write it as 2 in parentheses. We have 1 plus minus I, and 4 we can write as 2 times 2. So we can cancel these two. So as a result, our answer 1 plus minus I over 2. This is our k second and k third. And so let's write our final answer. In the end, let's check real quick our root, and I'm going to say a few really important thoughts about this question. So our answer to this question, so k first equal to 1/2. This is our real number root. And k second and third equal to 1 plus minus I over 2. 1 plus minus I over 2. So this is our solution to this question. And a few thoughts about this question, because as I said before, as I said in the beginning, this is extremely tricky question. First of all, let's check real quick our k first. So in the beginning we had k to the power 4 equal to k minus 1 to the power 4. Yeah, so let's check k equal to 1/2. So we have 1/2 to the power 4 equal to 1/2 minus 1 to the power 4. And I hope you see right now that 1/2 to the power 4 we have on the left side. We don't need to simplify it, but 1/2 minus 1 equal to minus 1/2. So right here we have minus 1/2 to the power 4. But as I said before, according to algebra tricks, I mean this one, so when we have minus 1/2, we can write as minus 1 times 1/2. And when we raise to the power 4, we need to raise this minus 1 to the power 4, which is equal to 1, because this is an even power. And 1/2 to the power 4, we leave without any changes. So our root is absolutely great. So we checked it. This root works perfectly. And in the end, as I said before, in the beginning, we had the situation. So I just want to underline it with an exclamation mark. When we have k to the power 4 equal to k minus 1 to the power 4. And as I said before, a lot of students cancel this thing, and we have k equal to k minus 1. I showed it in the beginning, but this is a wrong way, because right here we have 0 equal to minus 1. And I do not recommend you to cancel this power, because when you cancel it, you forget about other roots, because according to a fundamental theorem of algebra, when we have fourth power, it means that we have like 4 roots. These are like 4 roots in total. We don't know how many real number roots, how many complex roots. And if you cancel it, you eliminate like a complex root. You eliminate like one real root or 2 real roots. You eliminate roots. This is extremely bad thing you can do. This thing, my recommendation to do the thing if you don't have a time on your exam, if you have like 1 minute left and you need to write something. That's why maybe you can cancel this fourth part. But my quick tip, if you don't have a time and if you want to cancel this fourth power, because the correct way, of course, is to write everything on the left side, then consider like difference of squares, sum of cubes, these classic formulas. But if you don't have a time and if you want to cancel it, just write this quick absolute value brackets. Just write this quick absolute value brackets, and this is a correct thing. If you write this absolute value brackets, then if you have like 1 or 2 minutes more, you can quickly solve this equation with absolute value. Like this may be positive, this negative, negative, positive, and somehow like you need to spend like 3 minutes. Somehow from here you can solve it for k equal to 1/2. So according to this method, according to this absolute value, positive, negative, you can solve it for k equal to 1/2. So you can solve it like particularly. This is not like a full solution, but you solve it, you can get like some points according to this solution. Absolute value, then you consider like 4 equations. I don't know how do you solve this question in your country, how your teacher like explained this, but I teach something like that. We have two absolute value, maybe this positive, so we write this k, this negative, minus k plus 1. And a lot of combinations we have exactly right here. In this case we have 4 combination, plus plus, minus minus, plus minus, minus plus, and then we can solve for one real number. But according to this method, if you cancel this fourth power, you forget about complex roots. So yeah, this is not a full solution. This is only if you run out of time and you don't have any time, you have like 2 or 3 minutes left, then you cancel this absolute value brackets and then you have real number root. But you forget about complex roots. So this is like a I would say like maybe 30% solution. This is 100% solution because you solved it according to a classic algebra law, according to a classic thing. You factor, you write this identity, then you factor it, equal to 0. We have 2 parentheses, real number root right here. But according to this canceling, you forget about complex part. So this is my few thoughts about this question, because a lot of students like they don't understand how can we solve it. They think maybe you can cancel it, but of course you can do it, but with absolute value brackets. So I really hope you understand, but if you still have any question, write a question in the comments below. I'll try to answer, and of course we will discuss about the thing, because this is very, very tricky moment. If you cancel an even power, so we need to put absolute value brackets, because basically this k can be positive and can be negative. And with absolute value you can be safe about it. We have only one real number root. But in general, according to a fundamental theorem of algebra, we have 4 powers, so it means that we have 4 roots in total. We don't know how many real number roots, how many complex roots. In our case, we have 1 real number root and 2 complex roots. So that's why when we have 4th power, try to solve this question completely according to a basic school properties, according to a basic school formulas. Of course, you can pause the video and try to understand it. This is not that hard. We just consider it as difference of squares, basic school identity. Of course, not like a and b, x and y, but a little bit complicated with squares, but doesn't matter. In a few steps, we have a classic product of 2 parentheses, and we have our answer. So thank you for your time. Take care of yourself. Have a great day. See you in the next videos. Write your thoughts, write to respond in the comments below. A lot of students, teachers here, so that's why it's extremely great to exchange information, to see this question from a different angle. A lot of people, a lot of different countries, and this is extremely great that we are all here. I really appreciate it. Thank you for being here, for watching this video, for supporting my channel. See you in the next videos, and have a great day.